So this is the agent monitor demo, and so if we have an account, we can log into it. Otherwise, we can register over here. So we are supposed to enter username, password, and confirm password and register. So we have an account, so we will log in into it directly. So the username is user and the password will be entered, and we will be logging into that specific account. So then we have a basic UI where we can have a generate button, logout button, the previous chat history that we had done with it, and new chat if we want to. So then after that, I am going to test it with using a basic prompt. So let us give a prompt, generate a function to find the factorial of a given number. So then let us click on the generate button. So let us see. So it will generally take some time for that. So I have entered the prompt and it's generating code. Code is being generating. So let us wait. Yeah, the output has come. And we can see this is the initial code. And we can also able to see the enhanced code. So this is the enhanced code. So we can also see the image matrices and how the collaborative work has done, how many agents are used, and what is the latency of the code is being discussed will be given here. And this is the user board. And let us go to the admin board and check for that. So to log in into admin board, the username is admin and other things, password will be there, something. And then in admin board, we have total users, total prompts, and all this kind of stuff. So each for every specific user, we have a detailed information about his login history, logout history, and what are the prompts that he has given. So what are the prompts he has given also be there. So there is a list, and you can sort it according to the date or score. So we use score here. So let us check. So the prompt is create a React code for form. So this is the initial code and this is the final code or enhanced code. So image preferences are being there and agent level enhancement data is there. How much contribution is given by each agent is there. And this is the collective score XGBoost prediction model has given. This is the thing. And that's it.
So hello everyone, I am Kumaraswamy from Keshav Institute of Technology from group number G486, and today I will be presenting our project titled AgentMonitor, a predictive and secure multi-agent framework and agent-wise safety enhancement and visualization. So let me give a brief introduction about the project. So with the rise of large language models, we have seen the growth of multi-agent system where multiple AI agents collaborate to complete complex tasks, for example, coding, reviewing, and optimizing programs together. However, one major problem is that these agents often act independently without proper supervision. If even one agent produces an unsafe or low quality response, it can propagate errors through the system and affect the final output. To solve this, we developed AgentMonitor, a plug-and-play monitoring framework that observes, predicts, and enhances agent behavior in real time. Our goal is simple: to make AI collaboration safe, predictable, and transparent, where every agent's output is continuously checked and refined before passing to the next agent. So let us have an overview of the architecture. The overall architecture of AgentMonitor is divided into two major components: multi-agent system and AgentMonitor module. In the multi-agent system, multiple agents handle different stages of a task, such as code generation, testing, or optimization. Each agent performs a specialized role. So now the agent monitor module acts like a supervisor over the system. After each agent produces an output, a model called JudgeLLM evaluates. It's based on correctness, helpfulness, and safety. If the output does not meet the required threshold, it is passed to another model, the code enhancer, which refines or rewrites the output before sending it to the next agent, which is called as post editing. So finally all the corrections are made The scores and predictions are displayed on the web-based visualization dashboard, giving users a transparent view of what's happening inside the system. So in short, Agent Monitor acts as a safety net, ensuring that every agent's contribution is both reliable and safe before it moves to the next. So let us discuss about the enhancements that are made on the base project that has made. So when we started, the existing Agent Monitor framework focused mainly on observation and the performance prediction. We enhanced it by adding several key features. First, we introduced agent-wise safety enhancement, a fine-grained mechanism that monitors each agent individually. Instead of checking safety only at the end, we perform it every step. So unsafe or incorrect outputs never reach the next agent. Second, we added predictive performance modeling using XGBoost regression. This allows the system to predict the success of the entire workflow even before it completes, helping us identify weak points early. So third, we built an interactive front-end visualization using React. It shows real-time communication between agents, their scores, and safety corrections. So this makes the whole system transparent and easy to interpret. So finally, we designed the framework to be non-invasive and plug-and-play, meaning it can be easily integrated with any existing multi-agent system environment without major changes. Changes has to be made, but not many changes. Overall, these enhancements made Agent Monitor smarter, safer, and much more user-friendly. So next, what are the hurdles that we faced in making this project? So like any advanced AI project, we faced several challenges during development. So the first major hurdle was integrating multiple LLMs, JudgeLLM and Code Enhancer, and ensuring they worked in sync. Managing prompts and keeping context consistent across agents was complex, and the high computational load made it even tougher. So the second challenge was defining safety metrics. Measuring things like helpfulness or safety objectively is difficult, and sometimes our model were either too strict or too lenient. So we had to tune thresholds carefully to balance safety and creativity. And another hurdle was that training XGBoost model. So finding the right features to extract from agent logs took many trials, and we had to ensure our dataset was diverse enough to avoid bias. We also struggled with real-time visualization synchronization. Keeping front-end updates in sync with back-end processes required careful state management and asynchronous communication. Finally, there were resource constraints. Running multiple large models simultaneously demanded significant GPU and memory power, limiting scalability. So, but each of these challenges helped us refine the system and make it more resilient and optimized. So now let's discuss about the technologies that we are used. To bring Agent Monitor to life, we used powerful technology stack. On the backend, we used Python with frameworks like LangChain and AutoGen for multiple agents. For machine learning model, we used XGBoost regression model to predict performance, and used OpenAI GPT and Llama models as the core LLMs for the JudgeLLM and Code Enhancer. On the front end, we built an interactive dashboard using React, uh, along with HTML, CSS, and JavaScript for visualization. We also use Flask and Node.js for backend front-end communication and libraries for displaying safety metrics dynamically. In conclusion, Agent Monitor brings the gap between AI automation and safety assurance. It continuously monitors agent collaboration, refines unsafe outputs, predicts performance, and provides real-time visibility into system behavior. Our results showed a 6.2% reduction in harmful content and 1.8% improvement in helpfulness, and a strong match between predicted and actual performances. So moving forward, we plan to make the system more scalable, adaptive, and generalized across various AI domains. So to summarize, Agent Monitor is a step forward towards building trustworthy, transparent, and intelligent multi-agent systems.